We turn on this. So let's see how long it took it to ramp up from this point to that point. Okay, so we're bringing our curves, and okay, so we're saying it took it approximately 884 milliseconds. All right, 884 milliseconds to charge up. Okay, so if we do this again without the capacitor, but the capacitor causes for a ramp, okay, a delay in the rise of voltage. So we could use this to create delays in circuit. Okay, so where you can determine how long it's going to take for the voltage across a junction to rise above a certain level or to rise to a certain point, and you can have a circuit that will trigger a process once the voltage gets to that point. Okay, so that's how delay circuits are made with the capacitor and the resistor. Okay, so we can decide to use a different resistor to see exactly what our ramp will be like, or how long it's going to take for it to get to 2 volts across the LED. So let's quickly do that. Okay, so we have a new resistor fixed in. Let's see how long this takes us. Oh, we didn't put in a capacitor. Okay. In this case, we have a 68 kilo ohms resistor, and we have this ramp from it. And if we check it, we would see we have our ramp at 1.2 seconds. Okay, so it gets to 2 volts at 1.2 seconds. All right, it's from our calculations, we have 1.2 seconds. Okay, so we can understand that yes, we could use that formula to approximate when the capacitor is going to get fully charged, or when it's going to get to a particular voltage level. And then we could use circuits or a microcontroller to process a chain of events, okay, once that voltage level is reached. So for power factor correction, I have this device again. I'm going to be using as my signal source. Okay, so we're working with the 50 kilohertz signal, 3 volts wave and 3 volt sine wave. Okay, so I have here already a resistor and an inductor. Okay, I'm using the resistor as a means to calculate the amount of current flowing through the inductor. Okay, so let me connect my oscilloscope to that for us to see the signal going through it. So I turn on the signal generator and we have our signal. Okay, so So let me get the second probe to read what's happening across our resistor. Oh, this changed to 1000 Hz. I need it at 50,000 Hz. Alright, so we can see we have two signals out of phase. Alright, so our second probe gets us the reading across the resistor, which we're using to get the current flow through the network. Okay, so we have our first signal, the blue signal, showing us the voltage across the network, while we have our second signal, the yellow signal, showing us the voltage across the resistor, which we're using to deduce the flow of current through it. Okay, so if I place a capacitor across the coil, if I place a capacitor across the inductor, just observe to see what happens with the waves. Now we have the blue wave leading the yellow wave. So let's see what happens when the capacitor comes in. Okay, you see that has actually been erased. The wave now looks like it's in phase, right? Okay, so this is what power factor correction is about, and this is what happens when we use a capacitor to correct the change in phase between the current and voltage that comes from the influence of an inductor.